Oh, g'day champions, bit of a change of pace here. We've got Steinberger come in for just the restring setup and service, and this is actually the first time I've seen the Trans-Trem bridge in person. I haven't personally calibrated one before, but before I removed the strings on this one, I confirmed that the transposing was adjustable within range. I've just removed the strings, just started cleaning it a little bit, and I might take it apart just to freshen up the surface of those rollers a little bit. They've just got a little bit of tarnishing in some places. But the overall operation of the thing's fine. None of the rollers are seized. They're all spinning freely, so that's good. Electronically, the guitar's fine. There was a slight little dent on the fretboard, just a tiny little nick been taken out of it, so I filled that with cyanoacrylate and flushed that up and honed it back to the sort of satiny finish the rest of the fretboard has. It appears to be like a phenolic resin fretboard, and they appear to be stainless frets. I'll look up the specs on this thing just to confirm all that. This is just, I've taken it out, I've taken the strings off. This is what I'm telling you what I'm seeing, legends. Now there are some imperfections in the finish, almost like it's been refinished at some point. Reportedly it hasn't, but that to me looks like when you get a bit lazy, when you're sanding and polishing a guitar, you've got to sand it down to like 2000 grit before you can buff it. That looks like what it looks like if you miss a step, so you don't get all the scoring out from the previous grade of sandpaper. Not sure all the story behind it. The customer did ask about it, and I said, look, we could cut and polish that, but there's no guarantee we wouldn't go through the finish and then destroy it. And I'd say, look, just leave it how it is, just deal with it. It's an old guitar, it's got a little bit of sort of checking starting to occur in some places as well. I'm always hesitant to do any buffing work to a stain finish on a guitar, because if you do go through, well, guess what, you're taking the whole thing back to timber and staining and respraying the thing from scratch. Plus there's other considerations like the logo silk screen, something that you wouldn't be able to replace if you ended up losing it. So I told him, just live with it how it is. It's an older guitar, just accept that it's got a bit of character. So this is the first one of these bridges I've encountered. I had to do a bit of research. Everyone else seems to already know about them. I kind of only know about the stuff I've seen. Essentially the principle behind it is that you maintain the intervals between the strings during tremolo operation. And I'll show you what I mean. So you can hear there, as I was operating the tremolo, the strings were getting more and more out of tune to each other. The intervals were getting crazy different. Generally, the fatter strings will drop by more semitones than the unwound strings. So they'll go the floppiest first, technical terminology, whereas they'll stay closer to the original pitch. So everything goes way out of whack. On a traditional 2-point floating trem, say on a Strat or even a Floyd Rose, the intervals between the strings go out of whack to each other when you operate the tremolo, so your chord sounds out of tune. With the Trans-Trem, that's not the case. So because the thinner strings require more movement than the fat strings to change by the same amount of semitones, the way they got around it was by changing the pivot points. So the whole bridge sort of swings this way as you operate it. It sort of goes like that, it massively exaggerated, but that has the effect of bending these strings physically a further distance than these ones to maintain the same difference in pitch. Pretty ingenious, really. So not only do the intervals stay the same between the strings during tremolo operation, but it also has like a locking arm that allows you to transpose all the strings, taking advantage of that even in intervals between the strings, and allows you to transpose up and down in pitch by a standard amount. Now that standard amount is determined by the little machine notches in this little arm, which is where the trem bolts into. Alright champions, so I put it back together and was experiencing a little bit of binding, like the trem wasn't returning to its center position. If you pushed it down it remained a bit flat, and if you pulled it up it remained a bit sharp. So I thought I'd remove it to inspect it, check the bearings, but in the process we can show you how it works, what its principles are. So you can see the pivot point there, little pin. and the pivot point there, down lower. So that's about, I don't know, 8 mil from the top edge, and that's about 4 mil from the bottom edge. So that's how it operates. It moves the pivot points lower on the treble side, so it means the saddles, like through leverage, they move a further distance. Same angle, but because the pivot point's lower, they move a further distance this way compared to the base side, and that's the principle behind it. So pretty cool to look at it. Now you can see here evidence of the powder coat being sort of rubbed off as it's operated. You can see that area swivels down into the base plate, and it's actually it's moved forward under string tension, and now it's binding in that area. You can sort of feel it sticking when you're using it. Only just, but it's enough to mess up the tuning stability. And this is the area we're looking at here, the inside of there and there. So that's the housing for the bearing on this side. The housing for the bearings further closer to the top on this side, and the bearings are mounted on an angle. So I have to take the spring out, take the thing apart to have a look at the condition of the bearings. Possibly have to order some of them from the States. So nothing's ever simple at Brad's Guitar Garage. Comes in for a simple setup. Now we're ordering stuff internationally. Yay. Right, so these two cheeks come off here, and they house the pins that hold the bearings. So we've got to undo these 6 Allen key screws and carefully remove them. Right, so the whole base plate comes off, and then our end pieces pop off, leaving the bearings and their pins in place, which we can remove. Just feeling them, there is a little play, and that bearing's already come out with the end. So that's the tiny little bearings there with their hardened steel end pin. Doesn't feel like there's any notching, so maybe the bearings themselves are okay. There is a lot of axial play there. It does feel a little rough, so I think we'll need a new set of bearings for that. You can see here the areas more clearly where it's been binding up, rubbing on there and there. So that's what's causing it not to go automatically back to pitch when using the trem. So at this point, what I think I might do is call the customer and say, look, do you use the trem or do you just use the transposing? Because transposing, it's going to work fine because you're locked in by that machine piece. But if you want to use the trem free, you're going to have problems. So he didn't. The reason that makes me suspect that maybe he doesn't use the trem much is that he asked initially about the transposing not working, not intoning correctly on the G string only. Now that was an adjustment that I made before I took the existing strings off, and we sorted that out. But he didn't mention the trem not returning to pitch, and that was the first thing I noticed when I was trial playing it after a restring. So time to call a customer and go from there. But anyway, I thought you'd like to have a look at this, and you got to see its guts, which I was really hoping you wouldn't. Alright, these are the bearings the guitar came in with. The customer replaced the stock bearings with these ones. These are sealed ones from a aftermarket part supplier in the US. You can see the play there both in the outside of the bearing as well as the play from the axis, from the axle, the middle, inner housing, race, whatever you want to call it. And you can see here there's more difficulty getting the factory bearings in there, and once you get them in, they kind of don't move around as much. There's less play both in the outside of the bearing housing as well as in the axis. God, why do I keep saying axis? In the pin itself. So see there how much you can see the gap opening and closing either side of the outer race, whereas that doesn't happen with the factory included ones. Actually, champions, now we've taken the spring out, we can get a better sort of visualization of how it works. See the swing on it? Check out the swing on that there, boy. And going back to the stock bearings has fixed our binding problem too. And I did check that plate was bottomed out against there, and it is bottomed out again. But you can actually see light there now through the gap, whereas before you couldn't, particularly on that bearing housing area. It's just a close-up on the bearing housing there. You can see it's got a good at least half mil of clearance there now, probably 3/4 of a mil, whereas before it was actually touching. So I'm putting pressure there and it's not changing. So I think that will sort out our trem stability issue, or return to center issue, and it feels smoother now. You can actually feel it binding up before, just by putting pressure on with your hands. So no need to replace those bearings, they're still fine, and they're better than the replacements. So we'll put them back in, and chuck it back together. So here you can have a look at the string locking. They call them jaws in the documentation. You can see the string exits at almost the very top of this jaw. This is the first string, so the thinnest. So it needs to be as high as possible, as far away from the pivot point as possible to be affected the most. So this is for what would normally be the G string in standard tuning, so the thickest unwound string. And you can see the exit points at the bottom of the little jaw. And you can adjust, when we're adjusting the screw, we're adjusting the height. So essentially we're adjusting the string's exit point away from the pivot point. And the thinner the string is, the further it wants to be away, so it's affected the most by the angular change in the bridge body. Now remember, these aren't saddles, these just hold the end of the string. They do the movement, and then you got your roller saddles up the front that actually set your intonation, your action, and they allow the string to glide over it with these rollers. Anyway, now I've got to get this mess back together and tightened up and check that everything's stable. So this bridge design relies on strings that are a set length and that have a ball end on both ends. In this case, we're using D'Addario ESXL 125s as supplied by the customer. Calibrated for Steinberger and Steinberger licensed copies, including the Trans-Trem series, which is this one. Now the unwound strings I took off, it's almost like it's soldered. So these have got some kind of solder, just a lesser amount to the naked eye. Now that I look closely through my fantastic, always in focus Panny Boy lens, I can see the light of day. So this is a spot where there used to be a bit of a hole from taking a hit from something. I filled that with cyanoacrylate, so super glue, and burnished it to sort of match the surrounding area. There is sort of like almost like a satin finish to it. Back in the joinery trade, when we used materials like corian, we'd intentionally use a finer and finer grade of like Scotch Brite to get that sort of finish, to just take the shine off, to make it look less plasticky. Sort of almost looks like, yeah, they've done something similar to that, like burnished it with a mild abrasive. So you can see here there is a slight amount of fret wear, but very little. I believe these are stainless. So I'll just give them a polish with the fret guard there. I'll just use a little bit of buffing compound on a rag and just do it by hand. Alright champions, those frets are polished up nicely. I just gave the fretboard a lick of oil just to give it that dark look, but we didn't like soak it. So let's get the strings back on this bad boy and show you how the bridge works and how to adjust it. So holding the saddles captive, there's a little grub screw on one end. There's nothing on that end. So it's a like 1.5mm Allen key. It just holds pressure on the saddles, keeps them all blocked in. Seen similar stuff on some bass guitars like Warwick's. You can see there where the grub screws held pressure against the last saddle. But essentially they just float on two screws diagonally opposite. And to keep them all parallel and lined up, you just got pressure on one side, and because the machining's pretty tight tolerance, they'll squash into line. Now those saddles are spinning freely, so that's good. That's what we want, because otherwise we'd have to knock that pin out and remove the rollers and burnish them, which is basically cleaning up the pin and the receiver on the roller to make sure there's no friction there. I'd imagine you put a drop of lube in there before reassembly, but they're all spinning fine now, so we won't have to worry about that. Here's a bit of residue between the saddles, so I might just take them off and clean off whatever that is. So I've removed the saddles, cleaned under them, and just inspected that they're all fine. So I'll just tighten that screw up, not too much, just enough to hold them in place securely. Never mind the masking tape there, that was just me taking note of the existing intonation. So up at the nut end, if you want to call it that, it's more of a string retainer and a 0 fret. There's like a little rubber band. It passes under this string retainer and is held captive. I noticed the customer's got a few spares of them, so this one's still in good condition though, so we'll leave that on. So you load the string just by feeding it through there. And down this end, we've already backed the thumb screws off to remove the old string. The new string just goes in until it sits home, and just take up the slack with the thumb screw. And do that 5 more times. Now it does feel a little bit weird starting up at the nut end, and pretty much every other guitar starts at the other end as you're feeding the strings in, but it makes sense to pop them all in there at once and just put a little rubber band over, and now they're sort of held captive and they'll stay there while we're working on the other end. Right, now I'm kind of cheating in this one because I did test it with the old strings and made sure everything was adjusted and working well. I wanted to know if the new strings affected anything, and just confirm that I understand the bridge and how it works. Bear in mind, champions, this is the first time we've ever seen one, so we're reading the instructions while we're going. So the way to set it up is, according to the instructions, set the transposing arm up one step and tune knobs according to chart. And then you transpose to 2 steps down and you check the pitch according to that chart. Now if each string, once you've done that, is flat, you turn that little screw clockwise, and if it's sharp, you turn that counterclockwise. You repeat the cycle until there's no change. Alright, so here's my instructions. So we start up 1 step, and then we adjust it to down 2 steps, and we should have these notes. If they're out of pitch, then we need to adjust those screws. That's the way I understand it anyway. Alright, so we're aiming for F sharp according to the chart for what would normally be the 6E string. That's 1 step. Sweet. We'll tune the others to the chart. So we'll just give them all a stretch. Just make sure everything's bedded in. I do this with every guitar, not just this bridge type. Acoustic and electric. Just sort of settles the ball ends in, make sure everything's seated properly and everything's settled, and go again. So let's drop the pitch a little bit, just settling those strings in. Now we want to transpose to 2 steps down. So that's our middle setting there. It's got a little notch that it locks into. Then there's another one which is 1 step down. We want to go for the next one, which is 2 step down. Now where are we with the tuning? So we should have C there, but it's sharp. So that means we have to adjust that screw back. Sometimes the tuner gets a bit confused by harmonics, so I like to put it in the neck position and turn the tone all the way down, just to get rid of as many harmonics as possible. So it's just mainly fundamental left in the tuner. See the wheel's a bit more stable now. It was sort of jumping all over the place before because the harmonics confuse it. I found that's the case with most tuners. So F's a little sharp. Take that back a notch. It is so fun working around a camera tripod. So we want to go for B flat there, otherwise known aka A sharp. So we want E flat there, otherwise known as D sharp. C's about on the money. Alright, so we'll just give them another stretch and test that again. Alright, so that didn't take much at all. So now we're in tune again. We'll just go back down to 2 steps down and just check that we're about where we were before. So a little bit off. I think things are still settling in a bit. I love it when you're tuning up and a song just comes on that's in the same key. E flat, Screaming Jets. Thanks, Scotty. Listening to professional misconduct in the shop today. It's been going around in circles all day, trying to get to know the songs, you know. Haven't had a chance to really get to know the album. Alright, so we're tuned up and we've checked that the transposing is working as designed. So I'll continue as per any other guitar setup, doing the intonation and the action. So I'm really impressed by this little piece of engineering. It works as designed. After all these years, it's still functioning just fine. And just the precision required to get this to perform as it does. The precision in the machining and engineering, and it needs to be top notch. Like, you'd even have to take into account the thickness of the paint, that kind of thing. This little notched transposing lever here, that's just a piece of engineering art, that is. The machining accuracy of that completely determines the accuracy of the transposing of the pitch in this unit. So there you go, champions. I hope you enjoyed that one. It was educational for me. I hope it was for you too. Some of these instruments I haven't seen before because they're not as common in Australia as they might be overseas. So I have to sort of do a little bit of study when it comes in, just so I fully understand it before I attack it. Well, not attack it, but yeah, work on it. So very impressive. I just thought I'd do a quick video, partially because Lyle bullied me too, because he was always curious about these things. So I'll catch you on the next one. Don't forget to like and subscribe, or I'll stop sending you birthday cards. Take it squeezy. I'll catch you on the next one.